Hello, everyone. Good morning, good afternoon, and good evening, and namaste. Myself, Jayesh Pamnani, as a host of ICICT 2022. Dear authors and invited guests, welcome to the technical session 6C. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, you are well aware we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in this unpredictable situation and making this conference more productive. Also, we wish everyone and their families a protected time. We hope you will enjoy this knowledgeable and interactive digital session. Also, there is a special note for the presenters. You will be given 10 to 12 minutes for the presentation and 3 minutes for question and answer. On 10 minutes, I'll raise a gentle reminder and I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remark. Just before we get started, I would like to introduce you all to the chairperson for the session, Professor Minakshi Sumit Arya. Over to you, ma'am.
Hi, good afternoon, Jayesh, though we have it as good evening here, in fact, late part of the evening. But I welcome all to this 7th International Congress on Information and Communication Technology 2022. So as already brought out by Jayesh, we'll ensure that we are following the strict deadlines as far as time is concerned. So Jayesh, are we good to go with the first presentation?
Yes, ma'am, we are. So starting with the first presentation, we have Sivong Choi, and the paper title is Design and Implementation of Variable Blockchain-Based E-Voting System. I would request the presenter to please start the presentation and share the screen.
You're muted. You need to unmute yourself.
Hello. I am not shared my presentation. Transfer me the hosting writer.
I would request you to please try once again. I have given the access for the enable of the sharing screen.
Yes. Hello. I'm happy to present my study to you. My name is Seung Che. My presentation is in introduction. I explain definition and pros and cons and requirement of e-voting and related works. We will review the previous blockchain-based e-voting system. And next, I explain implementation of variable blockchain-based e-voting system. Last conclusion, I show how my study satisfied the requirement of e-voting. E-voting system use electronic ballot instead of traditional paper ballot. E-voting has classified according to voting place, poll site voting, kiosk voting, remote voting by electronic means. E-voting has a benefit on efficiency, accessibility, and economic facilities, but voters distrust about verifiability, privacy, fairness. And e-voting should satisfy the 7 requirements: completeness, soundness, privacy, unreviewability, eligibility, fairness, verifiability. Blockchain has a characteristic. Its ledgers are immutable and public. So the previous blockchain-based e-voting system has focused on enhanced privacy or verifiabilities. But previous studies are not satisfied both at the same time. Verifiability and privacy are important for voting system, but verifiability and privacy is stand in opposite side. So it's difficult to satisfy both at the same time. Therefore, we need the verifiable and the privacy e-voting systems. I explain implement of verifiable blockchain-based e-voting system. The systems are 6 stages: prepare stage, voting right registration stage, vote voting stage, voting process stage, and ballot counting stage, vote verification stage. The system has 3 areas: internet, private networks, and DMG. Blockchain and both mobile app use internet. The other voting systems use in private network. The WebSocket server communicate both internet and private network. Election prepare stage. Blockchain prepared and election auditing group are formed. The system and voters generate encryption key, and voters make his temporary blockchain address. Voting right registration stage work in voting place. Election officer, voter is identified by election officers. The voters register his voting blockchain address at smart contract of blockchain. Voting stage. In voting stage, voters present his blockchain address, and voters cast his vote at using by handwriting candidate numbers. The system is recognize candidate number from that image, and the hash of that image are signed by voters. And then that image are double encrypted by system and voters. The double encrypted image are voting evidence. It saved a voting evidence repository. The recognized candidate number are sent the voting process. In voting process, recognized candidate number are converted prime candidate identified number, and then candidate identified number are homomorphic encrypted. Next, that homomorphic encrypted candidate identified number are multiple encrypted by election auditing group. That multiple encryption candidate identified number is a ballot. It saved a ballot repository, and hash of homomorphic encrypted candidate identified number is stored in blockchain. Next, ballot counting stage. Counting system are gathering the ballot and decrypt. The result is homomorphic encrypted candidate identifying number. The system are count the number of voters in homomorphic encrypted state. After voting finished, if a voter wants to check his voter is reflected to result, then the voter present his blockchain voter evidence address and his private key to verification system. The verification system are get voting evidence and the decrypt that finally the voting system get handwritten candidate number image, and the voting candidate verification system get ballot and the decryptor. So the systems get the candidate identifying number. So finally, the voters can compare the candidate with the candidate identified number from ballot and candidate number from voting evidence. Candidate number is transferred prime candidate identified number. Product of prime number make easily count number of voters. I use a TensorFlow for candidate number recognition, and I use a various encryption algorithm. Previously, I said the voting system shouldn't satisfy the 7 requirements, and the privacy and verifiability is very important. In my research system, the system used Elgamal algorithm. Elgamal algorithm is a homomorphic characteristics. So the Elgamal make accurate counting. It makes a completeness. And this system is use a separate private networks. The private network is prevent attack of outside. It make a soundness. Blockchain address is separate, disconnect voters ballot from voters. It make a privacy. The smart contract of blockchain management manage the voters' voting right. The blockchain has a characteristic immutable. So smart contract prevent double voting. It make unreadabilities. The ballot is multiple encrypted. Multiple encrypted is prevent open ballot when during the voting. It make fairness. This system is poll-site voting. So election officer prevent vote of unauthorized people. This system uses voting evidence. If the voting evidence make voters check whether his voter is reflect the result or not. I showed whether this system is how I explained how my study satisfied the 7 requirements. Thank you for listening to my present.
Yeah, thank you, Sihung. So you have covered a very latest technology of blockchain. So could you tell me whether it is being implemented already in your country, or you are the one who has started this e-ballot through blockchain?
Pardon? Korea is use try the e-voting system, but not using blockchain is not common.
Okay, so this is your first time that you're using. What platform of blockchain are you using?
Pardon? I don't understand.
What kind of blockchain? Is it a public blockchain, a private blockchain? What
Yes,
kind of
I use Ethereum public blockchain.
Ethereum public blockchain?
Yes, but I modified that blockchain.
Okay. Okay, thank you so much. You can stop your screen share. Thank you.
Yes.
Thank you so much, sir, for the great presentation. And thank you so much, ma'am. Now, moving on to the next presentation, we have the paper title, What Machine Learning Can Bring to the Electrocardiogram Signal, a Review. And the name of the presenter is Jahoj Chenaf. I would request, sir, to please kindly share your presentation and share your screen.
Hello, everybody. Are you listening to me?
Yeah, hi, please go ahead with your presentation.
Yes, I have just recorded the presentation to facilitate the communication. So it will take 12 minutes.
Yeah, please
Okay.
start. Yeah. Yes, please start. You may start. Yeah.
Hello, I am Jawad Chenouf, a PhD student at University Mohammed V, Rabat, Morocco, and I will present to you my paper entitled What Machine Learning Can Bring to the ECG Signal, a review. We will be going through the following units. So we will begin by background and purpose, machine learning and ECG, and followed by results comparison, and finally giving you discussion and conclusion. Machine learning has become a topic of study in different applications in our life. For example, image recognition, speech recognition, object detection, and also medical diagnostic. The objectives of machine learning in medical area are to facilitate the complicated task of analyzing image scans and heterogeneous data. In addition, the need of capitalizing the expert's knowledge and make this knowledge available in all the world and accessible. This review presents a study of deep learning methods applied to ECG records. The number of research papers for machine learning dealing with ECG signal have been greatly increased during the past years. The results shown from PubMed database shows that the number of papers have increased from 36 in 2016 to 441 in 2021. And this is mainly due of significant number of datasets that were set to public. The electrocardiography is a technique that permits to measure the electrical activity of Earth. The ECG are the documents generated from this process. The ECG are inexplorable electronic documents that contain the history of electrical activity in certain frequency. It contains also other informations like the name of patient, the age, sex, and other information. In the standard, there are 12 leads coming from professional devices, but non-professional devices, there are maximum of 2, like for example, mobiles or smartwatches, and so on. These documents are very popular because of their low costs and because they are simply collected and no identity. In our review, we have two kinds of machine learning. There are traditional machine learning and there are deep machine learning. The difference between the two is the feature extraction. So feature extraction consists on experts feature that are detected, like for example, QRS detection, lack of P wave, or and so on. So we extract the feature and then followed by a machine learning classifier, like for example, SVM or INN, to extract the feature from this ECG. In opposition, deep learning do the job end to end, from the ECG to detect directly the disease, for example. As an imitation of feature extraction is that we require a data analysis from experts, and which take a lot of pre-processing. But limitation in deep learning machine learning is the lack of interpretability to give confidence to experts. This figure shows the percentage of contributing medical tasks in studied papers that exceeds 1%. Firstly, disease detection with 60%. It is mainly used as arrhythmia detection, AF detection, atrial fibrillation detection, hypercapnia detection, and other disease detection. 6% of papers are about emotion, mainly used for example, stress detection, human emotion recognition, pain recognition, anxiety. 7% are about signal quality, because the ECG data there are some perturbation coming from external factor. Some authors are interested in assessing the signal quality. In measured estimation, 7%. The objective is to estimate geometric measurements like blood pressure estimation, hypertension estimation, and others. Sleep staging with 66%. The objective is to detect the sleep disorders with machine learning. So there are interpretation 3%. Interpretation are used to interpret how machine learning works, to explain this to experts. ECG characteristic detection are used to localize identified parts in the ECG. There are also personal identification. The objective is to identify a person from the ECG records. There are also some works to reduce the false arrhythmia. There are some works to generate ECGs. Some works about teletransmission of ECG, mortality prediction from ECG, extend the age estimation from the ECG, and other works like the transfer learning. The most used models in our review are DNN. So the CNN though so many authors proposed architecture of CNN that were and use it for in ECG data. There are also decision tree, for example, random forest. It is based on a tree model of tests, and finally it gives one decision. There are autoencoder. It is machine learning that has the input like the same as the output. Or other authors that used LSTM, RNN, or GRU to see the time dependency, and other models that are less used in our selection of papers are SVM, CNN composed with LSTM. Also, there are many combination of CNN and other machine learning, logistic regression, introduced to CEF 5.0 algorithm, the restricted Boltzmann machine, deep belief learning method, and other combination. The most used data sets are the Visionet repositories. Also, there are data from hospitals, medical centers, university, but generally they are private. Other data sets like China Challenge, Kaggle, UCE, Manob is a data set that contains high quality recording of spontaneous emotion. The performance measures that were used are the accuracy, sensitivity, F1 score, specificity, accuracy. It depends on when classification, but they use some performance measure. And for example, in regression, we used the RMSE, MSE for the regression models. So, as limitation of words and that was detected by authors or that was detected mainly, that there is still of lack of interpretability. It's to give more confidence to experts to if we detect, for example, a disease, we can prove it. We can prove it that it works. And we can, and the expert will understand how the machine learning have given these results. There is still a lack of data sets. So many university, many centers that give this data sets and of public usage. There are many institutions don't make public data sets. They sell data sets. There is a lack of generalization because we have data in some countries, and we are not confident that it will work in the other countries in the world. And also there are other limitations. The opportunities is because there are the new portable and wearable devices that are used, rings, smartwatches, mobiles. So we can constitute big data sets to evaluate the understanding what we can bring. What we can found in the, as information from the ECG. Also, if we can give a combination of ECG and the other measurements, biological, biometric measurements, so we can detect disease from a combination of measures, and not only based on ECG at the time. So we have many measurements at in same time, and we can predict maybe predict the disease. we must improve the interpretability of models, and also to facilitate or to have some solution to minimize the number of parameters to have a performance models. And thank you.
Thank you so much, sir, for the wonderful presentation. I would request the chairperson if any of the question for the author.
Yeah, I just wanted to know one thing. Your paper was basically a review paper. So I couldn't see the end slide having the references that you have referred to, which led you to the conclusion of the techniques that you have discussed just now.
Yes, I agree. I just haven't added them into the presentation. Yes, there are 50, 180 papers that were studied, and it is a lot. We haven't focused on the specific domain, so I didn't add them in this presentation. Yeah, it's good remarks. I must add 10 the most significant, maybe. Thank you very much for the question.
Yes, and I just had one more input because I also work in the same domain. So what would really be great in case you can pick up a single data set and apply all the techniques and then probably come to a conclusion, like when you have shown the various algorithms, like you showed deep convolutional neural networks, you showed combination of CNN plus LSTM. So you have shown so many comparisons, but it's not clear whether the comparison has been done on a single data set or on multiple data sets. So probably you can even include that into your presentation by just taking a data set and applying all the algorithms on it and seeing what kind of an accuracy do you get.
Yes, thank you for the remarks.
Thank you so much. Thanks for the presentation.
Thank you.
Thank you so much, sir. Thank you so much, ma'am. Next, now moving to the next presentation, I would like to invite Abdel Ghani Azri, and the name of the paper title is IU Auto SVD++ and Item User Futures based into recommender system using conjunctive auto encoder and matrix factorization. Over to you, sir. And I would request you to please kindly share the screen and start the presentation.
Hello, can you hear me? See me?
Yes,
Yeah,
sir,
you're audible.
audible.
Yeah, I will share the screen. Can you see my screen?
Yeah, it's clearly visible. I would request you to please
Okay.
start the presentation.
Thank you. Hello, everybody. I'm Abdel Ghani Azri, a PhD student from Hassan First University, Morocco. I'm glad to present you our paper entitled IU ICICT++, an item user feature-based recommender system using contractive autoencoder and matrix factorization. Below is the outline. First, I will start by presenting recommender systems in general. Then I will present the recommender system types and its techniques. Then I will present the related work. Then I will present our contribution, which IU ICICT++ model. Then I will conclude by the experiment results and conclusion. As you know, it's hard to avoid these days recommender system because it's a platform that used by many companies to provide products, movies, etc. for customers based on historical user preference or order history. By providing a system of evaluation, it can be numerical via stars or via text. Many companies are using recommender systems such retail, streaming like Netflix, YouTube, social networks, for example, LinkedIn or other. For music, for example, Spotify or Deezer. For benefits of recommender systems, statically, companies who are using recommender systems have increased sales by 30% without forgetting client satisfaction. There are many recommender system types. We can speak about content-based recommender system, collaborative filtering, knowledge-based, demographic-based recommender system, context-aware, hybrid recommender system, and other like session or interactive. In our study, we will talk about content-based recommender system, collaborative filtering, and hybrid recommender system. For content-based collaborative filtering, for content-based recommender system, it used similarity computed between items to provide similar items to users. For collaborative filtering, it's compute similarity between users, so similar users might have similar items. In our work, we will combine content-based recommender system with a collaborative filtering in order to provide or to build a hybrid recommender systems. The techniques used, many techniques are used largely to build recommender system. We can talk about matrix factorization, machine factorization, transfer factorization, and deep learner techniques. In our approach, we will use, as discussed before, collaborative filtering and content-based. And as techniques, we will use matrix factorization and contractive autoencoder, which is a deep learning technique. For matrix factorization is a technique with used largely to build recommender system. The basic idea of matrix factorization is to factorize the rating matrix into low space matrix Q and P using latent factor K, which is very, very small than the dimension of the matrix. As related work, we have studied the ICICT variants or matrix factorization variants and the auto ICICT model, which is developed by Sachin Zhang and al. In 2017. Our model is has used the auto ICICT in order to build an extension of this model using a component using user side information, because many existing work don't include the user side information. So let's talk about the encoder, which we'll use it in this study. It's a deep learning techniques which based on two components, encoder and decoder. The main idea is to compute the input layer in order to construct the output layer using hidden representation. We have many types of autoencoder. For our study, we have used the contractive autoencoder. We have many applications of the autoencoder, for example, feature learning extraction, dimensionality reduction, and other application. But the main application of our work is feature learning. We'll talk later. So this is a representation of the contractive autoencoder, which proposed by Salah Fai and al. In 2011. The basic idea is to make the model robust against small changes by using a regularization term, using a norm, squared norm of Jacobian. Can find more details in the paper. The steps of our model: first, we extract feature for user. Firstly, we have using to what hot encoding which values between values containing only 0 if the feature is not present and 1 if the feature is present. Sorry, this is the user, the item, item feature, and this is the whole architecture. Sorry, the whole architecture of our models. T components, SVADI++, CIE for feature for user for item feature and another component for user feature. This is the prediction equation of our model. We can say the user feature and item feature is marked by if IE and if U. This is the loss function of our model. And for optimization, we have used the famous model stochastic gradient descent in order to learn parameters. For the data sets, we have used the famous data sets, Movilance, which is largely used for recommender system. For the data, sorry, we have 2,000 variants. One is 100K rating and 1 million ratings. For evaluation, we have used the right mean square errors. And for model training, we have split our data in 2 parts. One part taking 90% and testing data taking 10%. So we present the experimental results by analyzing the results of the experimentation. We can conclude that our model has the model outperforms the baseline compared with the auto-ICICT++ or auto-ICICT. We can also say the steps of convergence. Our model is better than the based model. For conclusion, we have proposed a hybrid model that outperforms some states of model. Adding user information has significantly increased the accuracy of the model. And for the future work, we plan to run the model in other data sets, real data sets, for example, Amazon or other, integrate some aspects, since the rating is a dynamic process, may change over time. Integrate other rich content such visual features and textual features, and integrate the model in an interactive recommender system to make it real to use. Thank you for your attention.
Thank you so much, sir, for the wonderful presentation. I would request the chairperson if any of the questions.
Hope I respect the time.
It was within a time.
Yeah, thank you.
Yeah.
Any questions?
Yes, a very good presentation that you have made. I just had 2 questions. So whenever we are making any machine learning or a deep learning model, we always have the issue of model overfitting. So when you are presenting your algorithm, I couldn't see what steps have you taken to ensure that the model is not overfitting.
Yeah. I think you talk about the parameters or the regularization terms. So effectively I don't present, but in order to avoid overfitting of the model, we have chosen parameter learning and regular parameters in order to avoid overfitting. Generally speaking, the parameters are between 0 and 1.
Okay, so so you have broken down your data set into 90% for training and 10% for testing, right? But I couldn't see any validation data set. If you have read the literature, you say that model is not overfitting only once your validation data set and the training data set curve, they follow the same pattern. Then only you take a testing data set. So probably you can also look at, adding, splitting your training data set into training and validation data set, performing your calculating your training and validation loss, and then using the testing data for testing how accurate your model is. So that's one observation which I had. You can probably include that.
Yes, thank you. This is a good remark. In future works, it's a good idea. Thank you.
Thank you, and wonderful presentation. Thank you so much. You may stop the screen.
Thank you.
Thank you so much, sir. Thank you so much, ma'am. Now, moving on to the next presentation, I would like to invite Mitchell Halbig, and the name of the paper title is Model Learning and Tactical Maneuver Planning for Automatic Driving.
Yes, thank you very much. I try to share my screen. Okay, I can't share my screen because, okay. Can you see my screen now?
Yeah, it's
yes,
visible.
All right. Yes, thank you. So my name is Michael Helwig. I'm working for Volkswagen and I'm writing my PhD thesis at the Technical University of Darmstadt. And today I want to present my paper, Model Learning and Tactical Maneuver Planning for Automatic Driving. The co-authors are Dr. Jens Höth and Professor Dr. Kornigorski. And as a quick side note, I do not speak for Volkswagen, so the results, opinions, and conclusions expressed in this presentation are not necessarily those of Volkswagen. First of all, I want to give you a short introduction. And about the motivation of this work and the goals, and then I show you our approach and then the results we achieve with our approach, and I finally give then a conclusion. Why should we use automated cars? So today, driver assistance systems already help to compensate for driver errors, and so increasing automation can make cars safer, more efficient, and more comfortable. And the driving task is divided into 3 components. So the motion planning. On the left-hand side, we have the mission planner, which basically calculates a route from the start to the end point. So if you type in navigate to London in Google Maps, it gives you the roads you have to drive on and the intersections where you have to turn. What the mission planner does not do is to consider other vehicles on the road or traffic rules and so on. So that does the tactical maneuver planning do. And it does make high-level decisions like accelerating, braking, maintaining speed, or changing lanes to cope with the traffic surrounding the ego vehicle. Based on this course planning, the path can be controlled by the feedback control afterwards. So the goal of this approach is to develop a safe and investigable tactical maneuver planning. That's also comfortable and efficient. Our approach is like follows. So we initially model an Markov decision process, and then we try to train the model in the simulations based on experience gained in the simulation environment. And afterwards, we want to calculate a new driving strategy with dynamic programming based on the new model. And finally, we evaluate the results, the model and the driving strategy in the simulation. So first of all, we have to model the initial Markov decisions process. Therefore, we define a state space. So we have a 2-lane road here, and we need the most important influencing factors on a decision-making instance. So we consider 3 other cars. So this is the front vehicle of the ego vehicle and the front and rear vehicle on the adjacent lane. Here we consider the distances to these vehicles and the relative velocities. Additionally, we consider the ego vehicle velocity to later optimize in a time-efficient driving strategy. We do a coarse quantization on these variables to achieve a discrete and finite state space that we can use for the MDP. Yeah, so with the reward model, we can determine how the car should behave. Therefore, we give a small positive reward for positive velocity of the ego vehicle. So the greater the velocity of the ego vehicle is, the greater the reward the agent gets. And we achieve a time-efficient driving strategy with that. On the other side, we don't want the ego vehicle to do lane changes all the time, so to drive in a comfortable way. So we give a small negative reward if the ego vehicle makes a lane change. So what we don't want to have at all is the ego vehicle crashing into other vehicles. So we give a big negative reward if the vehicle makes a collision. Lastly, for the initial MDP, we model the transition model. And we do it in a simple way here. The initial model is a deterministic transition model based on a simple point mass model. This model we want to improve in the simulation environment, what I talk later about. So before we improve the models, we want to apply the solution of the 2-lane road onto a 3-lane road. So we have on the top the modeling of the left situation and the right situation. So in the left situation, the ego vehicle is on the right and the adjacent lane is on the left. For the right situation, the ego vehicle is on the left and the adjacent lane is on the right. With value iteration, which is a dynamic programming algorithm, we can calculate the action values, which actually say how good a specific action is in a specific state. And we can combine these values to an extended state space with 3 lanes, and based on these combined Q values, we can take an action in the simulation environment. So now how do we learn the model or train the model? So on the top right, I have an example of a state transition model. So here from the state S1, if we do an action A1 accelerate, it can get into 3 other states. And we actually store the frequencies it gets in the state. So here it says the agent got from S1 to S2 1 time, from S1 to S3 2 times, and to S1 to S4 1 time. So if we experience a new experience in the simulations, we can modify the model. So here on the right bottom, we see that and transition is added. So it experiences a transition from S1 to S5. So we add these. And if it, for example, would have experienced a transition from S1 to S2, we can just count these numbers up. So the 1 on the top would be the 2 afterwards. So with these frequencies, we can calculate the relative frequencies which approximate the probabilities to for the transition model. And the advantage of this is that the learned system is totally transparent, and we can examine the model. And based on this new model, we can calculate a new driving strategy, which we can evaluate in the simulation later. So now I show you the whole framework. So on the top, we have the initial modeling of the MDPs. We can, I show you it with the pointer. So then we can calculate the the action value with the value iterations. Then we combine the action values for the extended state space, so that we can calculate the best action for this 3-lane scenario. We take the action in the simulation, then we gain experience in the simulations, and then we can divide the state space again into two lane road state spaces and update these models. So every 500,000 steps, we do value iterations on these updated models. And that is what I show you in the results. So here we have on the left side the proportion of collision-free episodes the agent made in the simulation. So we evaluated it over 1,000 scenarios each time, and we see that the agent gets, based on the learned model, gets much safer, and it ends with nearly collision-free episodes. Because the collisions were rewarded with a really high negative reward, so it were penalized, and so the agent learned to drive safer. On the right-hand side, we see the average velocity, and we see that it goes down and stays there pretty much. So because the agent got more safer, it drives more defensive, and that's logical. So what I have shown, so the model is completely transparent and investigable, and we could learn from experience in the simulation. We could reduce the state space and model complexity due to symmetry consideration. So we achieved could save memory and computational resources. And lastly, we showed that the driving strategy based on the learned model is safer than the initial model. And that's it. Thank you for your attention. And do you have questions?
Thank you so much, sir, for the presentation. I would request the chairperson if any of the questions for the presenter.
Yeah, hi Mika, thanks and congratulations for such a wonderful presentation. So I just had 2 questions to ask. So the model that you're developing is basically a reinforcement learning kind of a model?
We do dynamic programming here, so value iteration, which is in some cases seen as a reinforcement learning approach. But we don't do table-based reinforcement learning here. So we learn the model.
So my only concern was that when you are simulating it on a very ideal environment, like how much time would it take for this model actually to be brought out from the simulator onto the real roads? As in, what do you assume would be the success rate of this model if we actually start designing vehicles with this model incorporated into your vehicles?
I'm not quite sure if I understood the question right, but we learned the model in the simulations, where we approximate the real environment. What we have on the car later should be just the driving strategy. So the model is pretty big, and the driving strategy is comparatively small. And if we apply it on the car, the computational complexity is really low because it's just a table lookup in which state which action should be taken.
So have you given a thought of probably using some kind of a high performance computing platform like the ones provided by NVIDIA? Because I don't know whether you are aware or not, NVIDIA has recently signed a kind of a collaborative agreement with Land Rover. So have you thought of taking it onto a high performance computing architecture where probably the computational complexity that you're looking at that can be improved, or your model can become more robust? Have you kind of explored that area?
No, I've considered it, but I haven't done it. I've done it on my laptop here, so not high. Not so.
Okay.
That's
So you can probably try that out maybe in the future.
future research. Yeah, true.
Thank you so very much, Mika, for your presentation. Thanks.
Thank you as well.
Thank you so much, sir. Thank you so much, ma'am. Now, moving on to the next presentation, I would like to invite Laurent Berthani. And the paper title is Optimizing Berthing of Crew Transfer Vessels Against Floating Wind Turbines, a comparative study of various floater geometrics. I request the presenter. Yes, please. I request you to please share the screen and start the presentation.
Yes, I will try to share the screen. Good afternoon to all. Yes. Can you see my screen?
Yes, sir.
Perfect. Okay. So, thank you first of all for allowing me to present my my works. Briefly, since I don't have too many slides to show, this work comes from what could be translated as the French Maritime Merchant Navy Academy. So we provide masters for students on the deployment and maintenance of offshore structures. And among these structures, we provide maintenance for wind turbines. So we are going to talk about fixed and floating wind turbines. So basically, what is existing? What is the existing strategy? The existing assets. If you look the North Sea, for instance, you have in most of the cases monopiles which are driven into the seabed on the extending from the seabed to the surface. On top of them, you have the wind turbines. And the way you will berth against these monopiles will typically be with catamaran maintenance vessels. We are going to use the abbreviation CAT for catamaran. Yes, I forgot to say the purpose of this work is to be able for the wind turbine developers to determine the return on investments for their farms. So from a maritime point of view, if you look from above, so from a plane view, you may notice that the width of the catamaran is larger than the diameter of the monopile when the waves come from the left to the right. So we had to overcome some constraints due to confidentiality reasons. Most of the developers do not like to share the hull shapes. So we used a mathematical equation, which is called Wigley hull, which is a mathematical equation which gives a fair view of how such a hull would look like without infringing any confidentiality on the hull shape. So we used as a benchmark some work which are performed with the Hamburg tank test facilities. This data is public and is available on the footnotes in the reference notes. So for this test, Hamburg did a reduced scale model of a small 5.5 meter monopile. So in the real world, that would be 5 meter diameter at scale 1. Water depth in the real world would be 30 meter. We used some online softwares such as Gmesh for doing the mesh and Nemo for calculating the hydrodynamics. The efforts then that act onto the monopile and the hull are the incidental wave coming from the left to the right, and diffraction. Diffraction, for people who do not know much about hydrodynamics, is the fact that when a wave impacts the structure will tend to vibrate and generating subsequent waves. So in such a case, from a very pragmatic point of view, you may not, the catamaran is hardly hidden by the monopile. So there is no masking. In other words, to try to provide seakeeping for climbing on the boat landing is as if you were in an open sea. There is no harboring effect. On the other hand, if you look now at the floating structure, so this is inspired of some project of floating wind farms that we have in France that are being presently developed. So this is a 30-meter diameter floating cylinder. So now this time, if you look on the right side of the screen, on the plane view, it makes sense that the wave is hidden from the catamaran vessel by the floater. So on the left side, another phenomenon happens. For people who are not experienced to waves, waves is a phenomenon which is not only acting at the surface, but it goes all down to the seabed. And typically, if we use a very simple model, it will the movement of the wave particles, of the seawater particles, will be like an ellipse, whose long axis will decrease down to the seabed. So when you have an obstacle like this floating cylinder, what you have is that the wave movement is clipped. I don't think the word is proper in English, but in other words, on the right side, the maintenance vessel will not see the movement of the waves from the surface down to the keel of the cylinder. The maintenance vessel will only see the effects of the wave particles which moves further down the keel. And we are able to calculate what will be this residual wave motion, and therefore what will be the impact on the maintenance vessel motion. So in other words, to summarize, so we have a 30-meter cylinder, 40-meter draft, 2,000-ton displacement. Here we have a 70-meter water depth. And as I said verbally, so we have a clipped incident wave vertical force, while the horizontal force is simply masked. So the boat will not see any horizontal force due to the waves, but we will still have deflection because the floater will vibrate under the impact of the incidental wave. Now, another shape that is another real-world ongoing development in France. So this is actually there is even one prototype west of France presently being tested. So it is what we call a damping pool. So basically, it is a square, hollow parallelepiped. This time we have the same phenomenon, but the effect will be even less severe than for a cylinder. Indeed. So from the left side, so you still have the wave coming. Only the wave below the keel will go further from the left to the right, and you will have only a residual vertical load applying to the boat. Then for the right side, so on an elevation, on a plane view, sorry. So you easily see that the boat is completely masked from the waves by this parallelepipedal structure. So to summarize here, to give some order of magnitude, we talk about a 36-meter side square box, 7-meter draft, 6,000-ton displacement. On the prototype site, we have 23-meter water depth. As for the previous slide, the vertical force due to the incident waves is clipped, while the horizontal force to the incident wave is masked, but there is still vibration, therefore there is still deflection. Then what we use in order to not only provide unproven calculations, but to use benchmark, was to use several existing publications. So one of them is still the one from Hamburg I discussed earlier on. So here we have a side, we have an elevation of their small scale test. So what we use from their works is to plot the friction coefficient, of the boat against the monopile boat landing. So that is on the y-axis, while on the x-axis we plotted the ratio wavelength over boat length. So as the bottom right sketch shows, the wavelength is simply the horizontal distance between two crests of waves. Result speaking, so we worked out that we exceed the grip coefficient, which is the horizontal yield here, if the ratio of the wavelength over the boat length is more than 1.76. In other words, if the boat is longer, if the wavelength is longer than 1.76 times the boat length, it is impossible to use the boat landing. The boat will move too much. While if the wavelength is lower than 1.76 times the boat length, boarding on the boat landing will be possible. So, as I said verbally, the horizontal straight line is the grip coefficient, which is directly derived from a grip coefficient of rubber against wet soil. So then we use another benchmark, which is an office of Namal Architect in Norway. You will see the reference down on the slide. Their birthday limit will be rather 1.85, which is still fair for a comparison because they talk only about 5% accuracy, which is not too bad for doing comparisons. So then the results. So from all the structure that we saw, we work out different limitation for boarding with the maintenance vessel on the boat landing. Sorry. So to make it simple, here we did not account for the wave length or wave period. We just looked what the significant wave height would need to be in order to board whatever the wavelength is. Then you get the following table. So the cylindrical monopile 5-meter diameter is the standard one you have already got in North Sea. So typically for these structures, you need 1.5 meter HS. So that was for 30-meter water depth. If you work out what happens for floating turbines, so therefore with a cylindrical floater 30-meter diameter, then actually since your structure is larger, you have masking, and then you can still board with higher waves. So with 2.1 to be accurate, that is for 70-meter depth. Then if you increase the same geometry, so you will increase its diameter from 13 to 41 meter. So then the wavelength, the wave height, sorry, in order to be able to board, will still be a little bit greater. You will still be able to board with 2.5 meter HS, which is quite actually significant when you think from a maritime point of view. So then if you change the floater geometry from cylindrical to parallelepipedal, 36 meter side, you increase a little bit to 2.6, not that much. And eventually, if you go to the float gen prototype, which is the square parallelepipedal floater, in opposition to the upside, to the upper line, which was a plain parallel floater. So then you decrease slightly the HF to 2.3. What is quite amazing is that, okay, sorry. Why did I use this 41-meter elevator floater? It's just to get the same draft on displacement than the parallel floater in order to be able to work out the influence of the geometry as far as boarding is concerned. There is not much influence actually. You can see 2.5, 2.6, it is pretty much the same. The other thing I wanted to say is for the FlowGen 36-meter side, which is the existing prototype. Actually, I could have access to records in 2019, sorry, which gave a track record of 2.3 meter HS to be able to board. So believe me, I did not do any turn string exercise to get the results together. It just happened that the result was right the first calculation without any fine tuning. So 2.3 from my calculation against 2.3 from lessons learned from on-site maintenance. And the reference is shown below. So if we observe what happened on the table above, bursting limitation depends mainly on the incident waves and also on the deflection force. Otherwise, foundation geometry influence acts, actually does not act much, but mainly through the diffraction forces. Some practical consideration, obviously, if you look the size of the structure, so here this is a cylinder, 13-meter side cylinder, compared to below the 36-meter side parallelepipedal. So obviously, the above structure is much more dependent on the direction of the waves than the lower structure. So in other words, the square hollow box here is providing a harboring effect, while the upper floater, cylindrical, behaves as masking as long as the wave is directly horizontal. So the more the wave direction varies, the more floater width becomes necessary, a large floater width, in order to provide bursting by masking the waves. So we start to think about how to optimize boarding. So it would be possible to have a weather banning boat landing, for instance, something we are still considering. And obviously the present today is only based on unidirectional waves. So as just an indication, one of our future works will be to work out some machine learning out of this simple model. Well, thank you for listening, and I will be, of course, happy if you have any questions.
Yeah, thank you so much for the presentation. It was a very different domain that you gave a presentation on, and probably you're working on a live problem. Yeah. So I just had a few queries probably to solve my doubt only. So as of now, you're just working on a simulator. So have you thought of, putting the system into practice also?
Well, we have track records. That is a good thing. We have track records from boarding a vessel against a monopile, that comes from Germany. And we have track records for boarding a vessel against one of our prototypes in west of France. So it provides quite a good lower and upper benchmark in order to vary geometry between the two figures.
Yeah. So as of now, you're purely working on a mathematical model. Have you thought of introducing, some new kind of techniques that would be probably relevant, which will help you in prediction better, like for instance, machine learning or deep learning applications for the same?
Yes, that was what I was talking, but my accent is not good, so sorry, I didn't get what I said. Yes, that is one of our future works. We think about using machine learning. Just as a comment from the previous presentation, actually, I used some data from the automobile industry for working out the friction coefficient. So you see there are some synergies between completely different works.
Yes, so it helps wherever you have data. Probably machine learning will help you in at least, coming to a good conclusion. So I wish you all the best for your research, and it was a
Yes.
wonderful.
Yes, thank you for your interest.
Thank you. Thanks.
Thank you so much, sir. Thank you so much, ma'am. Now moving to the next presentation, we have Joachim Neto, and the name of the paper title is Geometric and Physical Building Representation and Occupants Movement Models for Fire Building Evacuation Stimulation. I would request the sir to please start the presentation and share your screen.
Thank you. I think you are seeing my presentation.
Yes, sir.
Okay, I will start. Thank you all for attending my presentation concerning the two new models, the geometric and physical building representation, and for occupants movement models for application in fire building evacuation simulation. My name is Joaquim Neto. I'm a PhD student in Portugal at Universidade Aberta. The outline of my presentation is what follows. You start with the problem statement and motivation for this work, the related work. You will present the building representation model, the modeling of occupants movement, and how we evaluate the models and conclusions and future work. Concerning motivation, this research work falls within the scope of our ongoing PhD thesis, under which we are studying how a multi-agent recommender system can guide the occupants of a building to a safe place in real time during a fire emergency situation. So we are developing a prototype of a multi-agent system for that purpose, based in context and high the Internet of Things that connect all the devices in the building. Due to the specificity of this research work, a web simulation platform in development at my work at the LANEC, National Laboratory of Civil Engineering, Portugal, will be used to integrate and test the prototype. That web simulation platform is supported on two new models that are the aim of this paper. A novelty model for buildings physical and geometric representation, and a new model for the occupants movement simulation. Concerning related work, the research in the area of building evacuation modeling has seen significant developments in the last decades, namely in the area of modeling and simulating the occupants movement. In our literature review, we identified three different modeling approaches: optimization models that treat the occupants as a whole without taking in consideration the individual behavior of the occupants; simulation models that intend to represent the behavior of and movement of the occupant while evacuating. This kind of models looks how each individual, each pedestrian moves inside the building. Risk assessment models that take in consideration and identify the hazards and risk in the building. Other authors also distinguish between microscopic and macroscopic evacuation models Microscopic models are based on simulation and can model the occupants' characteristics and interactions that influence their movement. Macroscopic models do not consider individual behaviors, as I told before, during evacuation and use optimization algorithms. Evacuation models can also be classified as discrete, as is the case with cellular automata model that we will use as the basis of our proposals, or continuous, as the models is based, for example, in the fluid dynamic theories that we not consider in our approach, or a combination of both. So we will present the two new models that we propose in our paper. The first one concerns the building's physical and geometric representation, and the second one to the occupants movement model. Concerning the building representation model, we support the model on a matrix where the elementary cells result from the decomposition of the building floor plans. Each floor of a building is decomposed in elementary cells, as we exemplify in this image. The characterization of each side of the elementary cells gives the geometric shape of the building. As you can see, you have fictitious sides that has not walls, or have real interior walls, or outside ones, as well as windows and doorways. You can represent the building using that kind of tool. As well, we also could represent in our model the different sensors or automatic fire detection systems or digital signage in the building that are important for the purpose we have in our PhD thesis. After transforming each space into a set of elementary cells, the next step is determining the occupants' paths to exit the building. As I see in the left side of these pictures, to achieve this, the cells representation must be transformed into a node network, to which the graph theory can be applied to find the shortest and safest path between any two nodes. The graph's edges result from the connection between adjacent nodes and represent the occupant's paths to exit the building. The distance between the nodes is the weight of each edge, the weight of the node of the graph. Concerning the occupants movement model, the occupants move along the building's traversable cells and doorways, represented by the graph's nodes and edges. Our occupants movement model follows this cellular automata paradigm. In a more traditional cellular automata model, each cell has the appropriate size to accommodate a single occupant, typically 40 centimeters by 40 centimeters, and the adjacent cells are only a step away. Thus, an occupant on a node can pursue their way by moving to another one of the adjacent nodes. The graph's nodes represent the elementary cells and the doorways in our building representation model, as before told. However, in our model, we do not need to decompose the building in 40 by 40 centimeters elementary cells, allowing a building to be represented by a significantly lower dimension graph, leading to computational advantages. Instead of one occupant per node, as on a traditional CA model, the number of occupants is proportional to the cell area that corresponds to that node. You have different areas for the elementary cells, as seen in the pictures. As the graph nodes positions are the coordinates of the cells and doorways, geometric centers, the occupant's distance to travel to the adjacent node is, of course, variable. It depends on the area of the cells and their position within it. Thus, the occupant's movement cannot be made from one node of our graph to the adjacent one, because in one step, because it is far distant from that, and we have to model the movement between the nodes. Okay. Our two-level CA approach model explores the advantages provided by the building representation model presented before, and we create a new model for the occupant's movement that consists of two phases: a macroscopic level phase, where the various occupants on a node may be seen as moving as a whole to the next node, and a second phase that we call microscopic level for simulating each occupant's movement at microscopic level, where we consider the occupants move over the graph's nodes and edges through the cells and doorways. So in our work, you consider three strategies for the occupant's movement. The first decision making is if the occupants are or are not familiar with the building. If the occupant knows the space, the occupant continues his way to the exit, following the safest, shortest path. They know the building, they know where exactly is the exits, and their choice is to go to the nearest and safest path. And in that case, you can use the graph theory and adopt one of the algorithms commonly used to solve the problem of determining the shortest path. You use, for example, Floyd-Warshall algorithm, as other algorithms may be also used. If the occupants don't know the space, two strategies are considered in our model. It follows the emergency signals installed in the building, or in the absence of signals, which is usual in residential buildings, small residential buildings, that are the basis of this project is to, because the basis of this project initially is to analyze the fire safety conditions in buildings already built and residential ones. In the absence of the signals, the occupant continues on his way, moving to at each moment to the nearest doorway in his field of vision. So these are the three strategies that we consider in our web simulation platform. Concerning macroscopic level movement, based on the chosen strategy, an occupant positioned on a node of the graph moves to an adjacent node according to a cellular automatic-like model. So at phase one, the occupant knows the next node to pursue in his strategy establishing his movement direction. However, because the distance between the nodes is more than a single step, the occupants move to their destination according to the microscopic level movement phase model that we present in the next slides. So each elementary cell is virtually divided into a grid for modeling the occupant's movement at the microscopic level. Each grid consists of L plus C square multiplied by C squares of 40 by 40 centimeters, where L has that conditions, and an occupant positioned at a square of the grid moves to an adjacent more neighbor square until he reaches a square that leads him to the next node, as marked by green in the left side of these pictures, or blue in this side of the right pictures. So the occupant's movement to the upper left adjacent node, for example, to the upper left adjacent node, graphic representation and
Sorry for the interruption, sir. Sorry for the interruption. Due to the time restrictions, I would inform you that you have 2 minutes more to go for the presentation.
Okay. So this exemplifies the movement of the occupants. To evaluate the models, we developed a web simulator platform with two subsystems, a web platform that allows to wield the physical and geometric representation, and a multi-agent system for simulating the building evacuation. For experimental scenarios, you represent the 2,000 square meters of our Congress Center, and we consider the an hypothetical Congress with 350 people. And the picture shows the pattern of the evacuation and the differences of the occupants. Our conclusion at the simulation tests demonstrate the platform's viability. The main contributions concerns the new building geometric and physical representation that allows to represent the building with a much lesser dimension graph, and the proposed two-level CA approach uses the benefits of the geometric building representation. For future work, we plan to integrate geometric data from CAD applications, integrate a fire propagation model, and also, as the main purpose, integrate our prototype of a multi-agent recommender system under development to test and evaluate it in the scope of our ongoing PhD thesis. And thank you all for attending me.
Thank you so much, sir, for the wonderful presentation. I would request the chairperson if any of the questions for the presenter.
Yeah, thank you so much. So nice domain that you're working on. It will be very, very beneficial for places which are very prone to fire. So I just had a few observations. One, you have not homed down on any specific algorithm for the shortest path, shortest path, any algorithm. Like you mentioned that you will try Floyd-Warshall or something like that, but have you kind of worked on any specific algorithm like Dijkstra's or Floyd-Warshall? Have you implemented that?
I only, at the moment, I only implemented the Floyd-Warshall algorithm, but the model is a multi-agent system that is already prepared to accommodate on real time other algorithms. Okay, you provide an interoperability data that allows that other kind of algorithms could be used for determining the shortest path.
Okay, and also you did mention that some kind of a recommendation system that you are going to, build on later. So
you are building a context-aware recommender system supported on Internet of Things, in the sense that you will have sensors and IoT devices in the building that the sensors will carry out data for the recommender system to process that data to determine the context and in some way tell to the digital signaling to orient, to guide the occupants of the building.
okay, so basically you are making it for let's say huge buildings where there is susceptibility of fire, where the recommender system.
Yes. Our work is related with a building in a fire emergency. Okay, you already tested a fire propagation to simulate the situation. Now I'm only presenting these two models, because if I divide, for example, if I divide our Congress Center on 40 by 40 centimeters, I need more than 11,000 nodes for my graph. With this configuration, I have 394 nodes. So in terms of computation, it seems to be more efficient.
Yeah.
It's
So
our expectation that may be a solution for the future.
Yeah. Thank you so much. Probably you can look at cloud platforms for simulating, or you may use infrastructure as a service. You may hire it from some kind of a service provider.
Yes, with 5G, it is possible to put the server of the server of the recommender system in the cloud and receive data from using the Internet of Things.
Yes. Thank you so much. Thanks for the presentation.
Thank you. Bye.
Thank you so much, sir. Thank you so much, ma'am. Now, I sincerely thank our authors for their excellent presentation, contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting the digital certificate through an email within 2 working days. Further, all the papers have already forwarded to the Springer. The publications will be live within 5 to 6 months. Kindly cooperate with the team of ICICT 2022. I also thank our session chair, Meenakshi Suvit Arya Doctor, for chairing the session. A token of appreciation to the chair on behalf of the team ICICT 2022 and Global Research Foundation.
Thank you.
Thank you so much. Thank you.
Thank you.
I would request the chairperson if any of the closing remarks for the session.
So it was truly a very, very wonderful session. Generally in sessions, you'll have papers pertaining to the same domain. So it was really amazing to see somebody presenting their research on maritime research, somebody presenting about how machine learning can be used for, fire evacuation system, also how you can use it as a recommender system. So it was a very, very holistic session that we had, which gave us a different perspective on various domains on which, the work is being done. And I would just, with a closing remark, I would just tell everybody that if you are, if your research is data intensive, you must try to incorporate some kind of a element of machine learning into your research. And it's a huge domain. So wonderful courses on Coursera by Andrew NG, which you can explore. That will give you a very different perspective on what all is available and how you can use the capability of machine learning in progressing your research. I wish you all the best for your future research. And do connect with us in case you need any help, guidance, or assistance. It was wonderful chairing the session. Thank you.
Thank you so
Thank
much,
you.
ma'am, for the
Thank you.
valuable
Thank you so
time.
much.
Before ending the call, I would kindly request to all of the to turn on the cameras for a quick snapshot of the virtual conference for a memory. Thank you so much. That's the end of the session. I would request to all to leave the meeting or end the call. Thank you so much for your valuable time.
Thank you.
Thank you.
Thank you. Have a good day.